Welcome to Chapter 6 on Soil Physical Properties. As Franklin D. Roosevelt stated, "The nation that destroys its soil destroys itself." This video introduces the field of soil physics, focusing on understanding the physical properties of soil. A physical property of matter is a characteristic that can be determined without changing the chemical identity of a substance. Examples include length, color, density, and mass. We can determine physical properties using our senses, such as sight, hearing, touch, and smell, as well as by measuring things like temperature. Specifically, the physical properties of soil refer to characteristics that describe the soil's physical state and structure. Key physical properties of soil include texture, structure, bulk density, consistency, crusting, temperature, and aeration. Ideal soil composition is typically 45% mineral, 5% organic matter, 25% air, and 25% water. Coarse fragments, or rock fragments, are larger particles, greater than 2 millimeters, that pose a problem for tillage and do not significantly contribute to important soil properties. We will focus on particles less than 2 millimeters for classification. Soil separates, also known as fine earth, primary particles, or textural fractions, are classified based on their equivalent diameter. The main soil separates are sand, silt, and clay. These three fractions, including the pore space between them, form the matrix of the soil. Different organizations, such as the International Society of Soil Science, the United States Department of Agriculture, and the British Standard Institution, have varying classification systems for soil separates based on particle diameter. Here you can see a comparison of the particle diameter classifications across the International Society of Soil Science, the United States Department of Agriculture, and the United States Public Roads Administration. The sand fraction has large diameters, excellent drainage, and low water holding capacity. The silt fraction is medium, while the clay fraction has the smallest particles, poor drainage, and high water holding capacity. Silt is highly susceptible to both wind and water erosion. Clay is the chemically active fraction and is associated with high compactness and buffering capacity. Conceptually, the combination of sand and silt forms the skeleton of soil, while clay is referred to as the quote, flesh of soil due to its active role.